Welcome to the deep dive. If you've been navigating the AI world recently, well, you know that large language models LLMs are pretty revolutionary.
Absolutely. Huge general knowledge engines. Powerful stuff.
But for businesses, for enterprises, they hit two big walls almost immediately.
Right.
First, that knowledge cutoff date, right?
Yeah?
Their worldview is stuck in, what, 2023, 2024?
Yeah, that's a major one. And maybe even more critically, they know absolutely nothing about your company's internal world.
Exactly. All that valuable stuff, the secret sauce,
Yeah.
locked away in PDFs, presentations, emails, meeting notes.
It's just not accessible to the standard models. And that's the bottleneck we're really talking about today.
Right. How do you unlock that value? How do
Yeah.
you make these powerful generalist AIs actually useful, strategically useful with your data?
So that's our mission for this deep dive. We're going beyond just the buzzwords. We'll start with the foundations people talk about: RAG, fine-tuning, prompt engineering. But we want to push into the more advanced techniques pretty quickly. Things like Agentic RAG, RFT training, CAG for speed, and GraphRAG for structure.
Okay, so quite a journey ahead. Let's frame the core issue then. We have this amazing but kind of generic AI brain, and we need to give it this specific knowledge, the institutional memory, to be an expert specifically for our company. How do we do that?
And right there, you hit the central tension. It boils down to this. Do you try to permanently change the model's internal wiring, its core knowledge? That's fine-tuning.
Okay, baking it in.
Or do you leave the core model alone and just give it the information it needs externally right when it needs it? That's RAG.
Got it. Augmenting the input.
And choosing between them. It's not just technical, it's deeply strategic. What matters most? Fresh data, speed, being able to show your work, that transparency.
Yeah, you pick the wrong tool for the job, and you're looking at wasted effort, unreliable results.
Exactly. It's about aligning the method with the actual need.
Okay, let's start with Eric, Retrieval Augmented Generation. It feels like this became the go-to answer almost overnight for enterprise AI. Why is that? How does it actually work?
Well, RAG is popular because it directly addresses that proprietary data problem and the freshness issue, too.
Right.
The core idea, like we said, is the base LLM itself. It stays unchanged.
Right, no retraining the big model.
Exactly. Instead, you augment its input dynamically. So you take your company knowledge, all those documents, and you break them down into smaller, meaningful pieces or chunks. And these chunks get indexed, usually in what's called a vector database. It stores them based on their semantic meaning, not just keywords.
Okay, so if I ask a question like, what's our Q3 marketing budget for Europe? What
Right.
happens next?
Right. Your question, what's the Q3 budget? It gets turned into a numerical representation, too, a vector.
Okay.
Then a component called the retriever searches your vector database. It looks for chunks whose meaning, whose vector, is closest to your question's vector.
So it's finding conceptually similar information, not just matching words.
Precisely. It pulls back, say, the top 3 or 5 most relevant text chunks it finds, maybe snippets from a budget report PDF or a strategy doc.
And then,
Those retrieved text chunks are then literally stuffed into the prompt right alongside your original question. That's the augmentation part.
okay.
And then finally, the LLM gets this combined prompt your question plus the context chunks, and it generates the answer based only on that provided information. It's synthesizing from the documents you just gave it.
Okay, now I see why it took off. The business advantages seem really clear. First, data freshness. Instantly.
Yep. If the budget changed yesterday and the document is updated, RAG sees the new version. The LLM's old training date doesn't matter.
And second, that transparency point. Groundedness. You can actually point to the source, right?
Huge, especially in regulated industries. You can say, the answer came from these specific paragraphs in document XYZ version 3.2.
That's critical for finance, legal, healthcare, places where you have to show your work. An opaque model just won't cut it.
It's the audit trail. RAG provides it. And of course, it keeps your confidential data safe because it's only used at query time, not baked into some public model.
But it's not perfect. There are risks, you mentioned, especially around that retrieval step.
Exactly. RAG lives or dies by the quality of that retrieval. The retriever has to find the right information, the actual answer within that huge database.
The needle in the haystack problem.
Yeah, or sometimes it retrieves things that are sort of related but not quite right, or just noise, and the LLM only sees those few retrieved chunks.
Right. So if the retriever messes up,
Garbage in, garbage out. The LLM might give a wrong answer, or even worse, hallucinate something plausible based on irrelevant context, even if the correct answer was somewhere in the database.
That sounds like a significant challenge. And you also mentioned latency.
Every single time someone asks a question, you have that extra step. Vectorize the query, search the database, retrieve the chunks, then send to the LLM.
That adds delay. Every time.
It does. Maybe it's milliseconds, maybe more, but it adds up. And it adds computational overhead, too.
So if I need like super fast responses for a real-time customer chatbot, RAG might be too slow.
It could be. That constant database lookup is a performance drain compared to a model that just knows the answer internally.
Which leads us perfectly into the alternative, fine-tuning.
Exactly. If RAG is about giving the model external notes, fine-tuning is about actually teaching the model, changing its internal knowledge and behavior.
Okay, walk us through that. How does fine-tuning change the model itself?
Fine-tuning actually modifies the internal connections, the weights, of an existing pre-trained model. You do this using a smaller, very specific data set that you create.
Not just random web text, but targeted examples.
Very targeted, usually thousands of high-quality, labeled input-output pairs. Think, here's a complex customer support question paired with, here is the single perfect company-approved answer. You feed these examples to the model, and through a process called backpropagation, it adjusts its internal parameters to learn the new facts, the specific company jargon, maybe a particular tone of voice, or even complex reasoning patterns specific to your domain.
So it's not just learning what, but how to behave.
Precisely. That's often the main goal. You can fine-tune a model to consistently act like, say, an insurance regulator using the exact terminology and decision logic required, or adopt your company's specific branding voice.
And the big advantage there is speed at runtime.
Yes. Once the model is fine-tuned, the knowledge is baked in. When you ask it a question, it just generates the answer directly. No external database lookup needed during inference.
Faster responses.
And potentially lower operational costs because you don't necessarily need that separate vector database running just for handling queries.
Okay, speed and behavior control, those are the big wins. But the downsides seem pretty significant too, especially around keeping the knowledge up to date.
Absolutely. You're right back to the knowledge cutoff problem. If your company policies or market data change, the fine-tuned model doesn't know.
So you have to retrain it.
You have to do the whole fine-tuning process again, which means preparing a new data set, spending significant time and GPU resources. It's costly and slow to update.
That sounds brittle for dynamic environments. And you mentioned another risk, catastrophic forgetting. Let's define that clearly.
Right. Catastrophic forgetting is the danger that when you intensely train the model on your very specific, narrow data, let's say, only medical device regulations, it might overwrite or lose some of its original, more general capabilities.
Like it forgets how to do basic math and talk about history.
Potentially, yes. It becomes a super specialist in one area, but maybe gets, well, dumber in others. You might end up needing multiple models, one specialist and one generalist.
Okay, that's a serious trade-off. Which brings us to the third, maybe simplest approach, prompt engineering.
Yeah, this is really the entry point. Prompt engineering isn't about changing the model or the data store. It's purely about optimizing the question you ask, the prompt itself.
How so?
It's about crafting the input to better activate the knowledge and skills the LLM already has from its original training. Simple things like adding think step by step can encourage more logical reasoning.
Or giving it a few examples of what you want few-shot prompting.
Exactly. Or defining a specific persona. You are a helpful customer support agent. It guides the existing model.
The strengths are obvious. It's instant, right? You change the prompt, you see the result immediately.
Yep. Zero infrastructure cost. No back-end changes. It's the quickest way to get better outputs.
But the big weakness?
It can't add knowledge the model doesn't already possess. If the model was trained before, say, the latest product launch, no amount of prompt engineering will make it aware of that new product's features.
It only works with what's already there.
Right. It optimizes access to existing knowledge. It doesn't expand it. Essential skill, prompt engineering, but it has hard limits.
Okay, so we have these foundational tools. But as companies really start using RAG at scale, they hit those limitations we talked about. The standard R pipeline feels, well, a bit basic, maybe naive.
It is. Standard RAG is quite static. It retrieves data based on semantic similarity, feeds it to the LLM at the end, and that's it. It doesn't really think about the query or the context.
Like if my question needs info from two different places.
Standard RAG often struggles there. It's usually tied to one knowledge base, one index, and it uses the LLM only once for the final answer generation. It lacks decision-making capability during the process.
Which is where this idea of agentic RAG comes in.
Yeah.
Making RAG smarter.
Exactly. Agentic RAG elevates the LLM. Instead of just being the final synthesizer, the LLM becomes an active agent much earlier in the pipeline. It makes intelligent decisions before retrieval even happens.
How does that work? What kind of decisions?
Think of the LLM agent as an intelligent router or a tool user. It looks at the incoming user query and first tries to understand the intent and the required context. Let's say a big company has two main knowledge sources set up as tools for the agent. Tool 1 is the internal HR policy database. Tool 2 is an external industry benchmarks database.
Right, very distinct knowledge domains.
So a user asks, what's our company policy on using unlimited PTO during the Christmas holiday week?
Okay, clearly internal.
The agent analyzes this. It recognizes keywords like our policy, company, unlimited PTO. It determines this requires internal specific information. So it decides to use tool 1. It routes the retrieval only to the internal HR database.
Got it. It picks the right source.
Now, what if the same user asks, what's the typical PTO policy for tech companies in California around year-end holidays?
Different context. External comparative.
The agent detects that shift. Typical tech companies, California. It understands this needs external general knowledge. So it dynamically switches and routes the query to tool 2, the external industry benchmarks database.
That prevents mixing things up, giving an internal policy when asked for an external standard.
Crucially, yes. It ensures the context fed to the final generation step is actually relevant, avoiding confusion or contradictory information.
That sounds much more robust.
Yeah.
What about questions that don't fit either database, like who won the World Series in 2015?
That's where the fail-safe mechanism becomes so important for building trust. The agent analyzes the query World Series 2015. It compares this context to the available tools. Internal HR, external tech benchmarks.
No match.
No match. So instead of just randomly trying to retrieve something irrelevant from the HR docs, or worse, making something up, the sophisticated agent recognizes the mismatch.
And what does it do?
It triggers a predefined failsafe. It reports back honestly, sorry, I don't have access to sports history information. My current knowledge is limited to internal HR policies and external tech industry benchmarks.
That ability to say, I don't know, is huge. It stops the system from lying or guessing.
Absolutely critical for enterprise use. It maintains user trust. Agentic RI turns the LLM from just a writer into a genuine knowledge manager.
And managing all this diverse enterprise knowledge effectively, that brings us to the underlying infrastructure, right? Content-aware storage, or CAS.
Yes. You need a solid foundation to make these advanced RA techniques work reliably, especially given the sheer volume and messiness of typical company data.
We talked about that data dilemma. Less than 1% of internal unstructured data, PDFs, audio, emails, ever made it into the general LLM training sets. It's this vast, untapped resource.
It really is, and CAS is the set of technologies and processes that make that resource usable for AI, specifically through systems like RAG. It's more than just storage.
What does it involve?
It's about making the data cognitively accessible. This means sophisticated document parsing, handling complex PDFs, tables, images. It means intelligent chunking, breaking documents down semantically, and crucially, adding rich metadata before you even get to the vector indexing step.
So prepping the data so the agent and retriever can actually find and understand it properly.
Precisely. When you implement CAS, well, underpinning your RAG system, you see real operational benefits.
Like what?
Well, first, you start extracting insights from places you never could before. Analyzing thousands of hours of recorded meetings for strategic themes, processing years of customer feedback from social media. CAS plus RAG makes that feasible.
Okay, uncovering hidden value. What else?
Operational efficiency. Getting insights faster is one thing, but also remember how slow and costly full fine-tuning retraining is? With RAG-STIAs, you just incrementally add new documents to your vector store. Much faster, much cheaper to keep the knowledge current.
Makes sense. Faster updates, lower cost.
And all this leads to the third really strategic outcome, building what the source calls a cognitive edge.
A competitive advantage from your own data.
Exactly. You're leveraging your unique proprietary knowledge stuff your competitors just don't have access to. Your AI isn't just smart. It's smart in a way that's specific and valuable to your business.
which builds trust, improves accuracy, and makes the AI a real strategic asset, not just a tech demo.
That's the goal. CAS provides the foundation for RAG, and Agentic RAG provides the intelligence to navigate that foundation effectively.
Okay, we've got RAG, fine-tuning, and the smarter Agentic RAG. Now we're getting into even more specialized territory. Let's start with RAFT, Retrieval Augmented Fine-Tuning. That sounds like a hybrid.
It is. RAFT is a really clever approach that tries to get the best of both worlds, specifically addressing that core R-recommiss. What if the retriever brings back bad documents?
Right, the garbage in problem.
RAFT tackles this by fine-tuning the model, not just on facts, but specifically on the skill of handling retrieved documents, including irrelevant ones.
Ah, okay. The source material had a great analogy for this. If RAF is like an open book test where you didn't study, and fine-tuning is a closed book test,
then RFT is like an open book test that you actually studied for. You didn't just memorize facts, you learned how to use the reference materials effectively, even the confusing bits.
teaching the model how to fish, or maybe how to tell a good fish from a bad one.
Exactly that. It's about discernment. The way it works involves creating a very specific kind of training data set for the fine-tuning step.
How is it structured?
Each training example has 3 parts: the original query, a set of retrieved documents, and the desired answer, often formulated as a chain of thought to show reasoning.
Okay.
But here's the key. The set of documents is carefully constructed. Some documents are labeled core documents. They actually contain the info needed to answer the query. Others are labeled tangent documents. They're irrelevant, maybe misleading noise.
Ah, so you're deliberately feeding it noise during training.
Yes. In one type of training set, you give the model the query, the correct chain of thought answer, and a mix of core and tangent documents. This forces the model to learn, okay, I need to find the answer in these core docs while actively ignoring those tangent ones. It learns to filter.
That directly tackles the distraction by noise problem in standard RAG.
Precisely. But there's a second, even more specialized training set structure that's crucial.
It is.
Set 2 gives the model the query and maybe an answer like, I cannot answer this based on the provided documents. But critically, the document set contains only tangent documents, 0 core documents.
Whoa, so you're training it to recognize when the retrieved information is useless.
Exactly. You're teaching it to identify a knowledge gap based on the input. If the provided context is just irrelevant garbage, the model learns to say so, rather than trying to force an answer and hallucinating.
That's incredibly powerful. It directly targets the hallucination risk that plagues standard RAG when retrieval fails.
It does. By training for noise filtering and knowledge gap recognition, RAFT aims to make the model much more robust and reliable, even when the initial retrieval isn't perfect.
And using chain of thought for the answers helps with transparency too.
Yes, it encourages the model to cite its sources within its reasoning process, improving traceability. RAFT is a sophisticated technique for building highly accurate, grounded specialist models.
Okay, shifting gears a bit, let's talk about another alternative focused on speed. Cache-Augmented Generation, or CAG. How does this differ from RAG?
CAG is all about minimizing latency. Remember, RAFT involves a retrieval step for every query, which adds time. CAG tries to eliminate that retrieval step, at least after an initial setup. The idea is to front-load the knowledge.
Front-load how?
You take your entire knowledge base, and this is the catch, it has to be small enough, and you process it all at once through the LLM. The results are then stored directly in the model's internal key-value cache.
Okay, pause there. The KV cache. What is that exactly?
Think of the KV cache as the model's short-term working memory, specifically for its attention mechanism. When generating text, the model calculates key and value vectors for each token it processes. Storing these allows it to efficiently pay attention to previous parts of the sequence without recomputing everything constantly.
So CAG preloads the key value representations of the entire knowledge base into that cache.
If it fits, yes. Effectively, the model now has the entire knowledge base sitting in its internal superfast memory. When a query comes in that relates to that cache knowledge, it can access it almost instantly without any external database call.
That sounds incredibly fast for responses. But you said if it fits, what's the limitation?
Scalability. LLM context windows and KV caches, while growing, are still finite. You can maybe fit a few hundred pages, perhaps a small technical manual, into the cache, but you absolutely cannot cache millions of documents like you can index for RAG.
So RAG wins massively on scalability. It can handle huge knowledge bases.
Definitely. CAG wins significantly on latency after the initial cache build, but only for small, static knowledge bases.
Why static?
Because if the knowledge changes, even slightly, you have to rebuild the entire KV cache from scratch. If your data changes frequently, you're constantly rebuilding the cache, which negates the speed advantage entirely.
So the choice is stark. CAG is for speed on stable, small data sets.
Perfect example. An IT help desk bot using a single, unchanging 150-page product manual. Latency is key, data is static. CAG makes sense.
Whereas RAG is for scale and dynamism.
Right. Legal research across thousands of constantly updated court cases, you need RAG scalability and ability to handle fresh data.
But the source mentioned a clever hybrid use, using them together.
Yes, this is where it gets interesting architecturally. Imagine a clinical setting. A doctor needs info on a patient.
Okay. Massive potential data patient history guidelines.
Right. You can't cache it all. So first, you use RAG to retrieve a specific subset of relevant information for that patient, maybe their last 5 visit notes, current meds, and 1 relevant clinical guideline. A small, focused set.
Got it. RG does the initial filtering.
Then you take that small subset and load it into the KV cache using CAG.
So now the doctor can ask rapid-fire follow-up questions about that specific context dosage from the guideline, a detail from a pass note, and get near-instant answers because it's all in the cache.
Exactly. Super fast interaction for that specific task. Then, when they move to the next patient, you clear the cache and repeat the RAG, then CAG process. It's managing the workflow for performance.
That shows how these aren't necessarily competing methods, but tools in a toolkit.
Precisely. And that need for structure and understanding relationships brings us to the final advanced approach, GraphRAG, using knowledge graphs.
Okay, what problem does GraphRAG solve that standard VectorRAG doesn't?
The big one is context and relationships. VectorRAG is great at finding text chunks that sound similar semantically. This paragraph mentions Dr. Smith and Project Alpha. This other paragraph mentions Project Alpha and Q3 results.
But it doesn't connect them.
Not inherently, it just gives you the isolated chunks. It struggles to understand that Dr. Smith leads Project Alpha, which impacted the Q3 results. It misses the network of connections between entities across the whole dataset.
And GraphRAG tackles this structurally.
Yes. It changes the fundamental storage and retrieval paradigm. First, you use an LLM as an extractor to process your unstructured text. But instead of just chunking it, the LLM identifies nodes entities like people, companies, projects, concepts.
Okay.
And critically, it identifies the edges, the relationships between those nodes. Dr. Smith leads Project Alpha. Project Alpha impacted Mission Q3 results. The structured data, the graph, is stored in a specialized graph database like Neo4j.
So you're moving from bags of text chunks to an actual structured map of the knowledge.
Exactly. Retrieval then works differently too. A user asks a natural language question. The LLM acts as a translator. It converts that question into a formal query language for graphs, often cipher.
So it generates code to query the graph.
Yes, like find person X who is connected via collaborated on edge to Project Y, and also find the reported outcome edge from Project Y. The cipher query runs on the graph database, retrieving specific nodes and relationship paths.
And the results come back structured.
They come back as structured graph data, which the LLM then translates back into a natural language answer for the user, summarizing the findings and the connections.
The advantage seems clear for complex questions requiring understanding relationships.
Absolutely. Context depth is one huge win. You can ask multi-hop questions that are almost impossible for vector search, like which researchers who previously worked at competitor X are now collaborating on our main AI project initiated after 2022. You get higher insight because you're not just summarizing the top few text chunks, you can analyze patterns across the entire graph structure. And governance is potentially better, too.
How so?
Because the knowledge is explicitly structured as nodes and edges, it can be easier to trace exactly how an answer was derived, which nodes and relationships were involved. Potentially better explainability and access control.
So ideal for really complex domains: finance, intelligence, scientific research, legal.
Exactly. Anywhere that understanding the intricate web of connections, not just finding keywords, is critical for accuracy and insight. GraphRAG provides that structural understanding that vector search often lacks. #tag outro. So as we bring this all together, the main takeaway for you, the listener, isn't that one of these techniques is universally best. It really comes back to strategy.
Right. It's not if you specialize your LLM, but how, based on what you actually needed to do.
Precisely. If your absolute priority is data freshness and transparency, you need the latest info, you need to cite sources clearly, then RAG, maybe Agentic RAG for complex setups is likely your starting point.
Okay, but if it's more about controlling the AI's behavior, making it adopt a specific persona or jargon, and you need maximum inference speed at runtime.
Then you lean towards fine-tuning, possibly augmented with RFT, to make it handle context better.
And for those really complex domains where mapping intricate relationships and understanding the deep structure of the knowledge is key.
That's where GraphRAG shines, offering that network-level view.
And we saw with RAFT, and especially that hybrid RG then CAG example, the most powerful solutions are often combinations, right?
Definitely. Think about building a specialized AI for financial news. You might use fine-tuning first to teach it the specific language of markets, historical analysis patterns, how to structure a report.
Okay, bake in the core expertise.
But then you absolutely need real-time data. So you layer Agentic RAG on top to pull in livestock prices, breaking news feeds, economic indicator releases from multiple sources.
So you get an AI that has the deep knowledge of an analyst and the up-to-the-second awareness of a live feed.
That's the goal, a holistic system. Deep core knowledge, current and accurately routed context.
Which brings us to a final thought. We spent a lot of time on Agentic RAG, RAFT, GraphRAG techniques, where the intelligence isn't just in generating the final text, but in the sophisticated filtering, routing, and structuring that happens beforehand.
The preparatory intelligence is key, knowing where to look, what to ignore, how things connect.
So if we're training models using things like RAFT to filter noise like an expert, and we're building systems like Agentic RAG where the AI decides which knowledge source to use, and importantly, when to admit it doesn't know.
Yeah.
Are we moving towards a future where the most critical skill for an enterprise AI isn't just generating fluent language, but actually having a sophisticated, specialized self-awareness of its own knowledge gaps and capabilities?
That's a fascinating way to put it. Not just raw intelligence, but optimized wisdom. Knowing its limits and knowing how to effectively find what it needs within its specialized domain.
It feels like that might be the real cognitive edge, the AI that knows what it doesn't know and knows exactly how to find out.
That's definitely something to think about. The future might be less about bigger models and more about smarter, more self-aware, specialized systems.
Food for thought. We hope this deep dive helps you navigate these choices as you build out your own AI capabilities. Thanks for joining us.